Okay. The solid shaft of 200 mm diameter has the same cross-sectional area as a hollow shaft of the same material with inside diameter of 150 mm. So find the ratio of power transmitted by both the shafts at the same angular velocity. Second question, angle of twist in equal length of the shaft when stresses to the same intensity. Okay. So first of all, ratio of, first question we will complete. Ratio of power transmitted by both the shafts. Power transmitted both shafts. Both shafts. Okay. Both shafts. So first of all, for solid shaft, so diameter it is given D. Diameter of solid shaft it is given 200 mm. And for hollow shaft, so external diameter it is not given, that is D2 we need to calculate. Okay, and small d2 it is given, that is internal diameter. For hollow shaft it is given 150 mm. But cross-sectional area of both hollow shaft and solid shaft it is equal. Cross-sectional area of solid shaft equal to hollow shaft, Okay, so this data it is given for them. Okay, so area of solid shaft and hollow shaft it is given equal. Okay, so that's why A1 is equal to A2. You can say it will be area of solid shaft is equal to area of hollow shaft. The area of solid shaft area is pi into capital D square divided by 4 is equal to area of solid shaft pi into in bracket d2 square minus small d2 square minus small d2 square divided by 4 So we will get from this. So this pi it will get cancelled. This 4 it will be get cancelled. So capital D square it will be, this value it is known for solid shaft 200 square is equal to d2 square it will be how much? D2 square it will be unknown value. So D2 square this value it is unknown value. We need to calculate external diameter of hollow shaft. Then small d square it will be 150 square. Okay. 150 square. So it will be get D2 diameter of hollow shaft. D2 is equal to 200 square plus 150 square. Root of answer it will get 250 mm. So external diameter of hollow shaft it is 250 mm. Okay. So now ratio of power transmitted. Now power transmitted for, now calculate power transmitted for solid shaft. shaft. Okay, power transmitted for solid shaft. So for that, we know that equation T divided by IP. T divided by IP. T divided by IP. IP it is polar moment of inertia is equal to Fs divided by R is equal to T divided by IP is equal to Fs divided by R. Fs it is shear stress divided by R divided by R divided by R. So IP for hollow shaft we know that. So T divided by IP it is 5d raised to 4 divided by 32. Pi into d raised to 4 divided by d raised to 4 divided by d raised to 4 divided by 32 divided by 32 is equal to Fs divided by R it is d by 2. R it is d by 2. D by 2. Okay. So we'll get from this relation T is equal to pi into d raised to 4 into d raised to 4 divided by 32 into 2 by d 2 divided by d into Fs Okay. So this 2 ones are 2, 16 2s are 32. So this d cancel, it will get q. Okay. So now we can write down this equation pi into d cube divided by 16 into Fs divided by 16 into Fs. Yes. Put all this value till we get so pi into d cube, it will be for that 200 cube in terms of Fs. This value to be get divided by 16 into Fs. Okay. So we can say this one it is for solid Ts, power transmitted for solid. Okay. So Ts is equal to, I will write down here, Ts is equal to, with all this value here, portion for power transmitted for solid is equal to pi into 400 cube divided by 16 into Fs. So Ts, can write down Ts is equal to, so pi into 200 cap 3 divided by 16. So in 1.707 into 10 raised to the power 6 in terms of Fs, this value to be given. Okay, so now calculate power transmitted for hello. Now calculate power transmitted for hello. Power transmitted for hello. For hello. So this one it is also T divided by IP for hello section. We know that it is pi dt. This one it is pi into capital D raised to 4 into capital D raised to 4. So that is D2. Okay. Capital D raised to 4 minus small d raised to 4 minus small raised to 4 divided by 32 divided by 32 divided by 32 is equal to Fs divided by Fs divided by R, it is d by 2. R, it is d by 2. D by 2. D by 2. Okay. So this one it is for hello. So that's why you denoted by th, small th. Okay. So small th is equal to pi. So take t is equal to t is th is equal to th is equal to pi into capital D raised to 4 into in bracket capital D raised to 4 capital D raised to 4 minus small d raised to 4 minus small d raised to 4 minus small d raised to 4 divided by 32 divided by 32 into 2 by d, it will be get 2 by d, d by 2 it will be get in upper side it will be get d by 2, that is 2 by d. Okay, 2 by d is into Fs into Fs. Okay, so final value it will be 2 1 the 2, 2 to the 16. So we get pi into capital D2 raised to 4 minus small d2 raised to 4 small d2 raised to 4 divided by 16d divided by 16d divided by 16 into capital D into Fs into Fs into Fs. Put all this value here. Put all this value here. So it will begin. Write down is equal to Fs pi value into capital D raised to 4. It will be 250 raised to 4. 250 raised to 4 minus 150 raised to 4 minus 150 raised to 4 divided by 16d divided by 16 into capital D, it is 250. In terms of Fs, this value to be get in terms of Fs is equal to, so pi into 250 raised to 4 minus 150 raised to 4 divided by 16 2 pi 16 into 250. In terms of Fs, it will be get 2.670 into 10 raised to the power 6, 10 raised to the power 6 Fs. Okay. So now power transmitted by, now we can, okay, power transmitted by hollow shaft to power transmitted for solid shaft divided by power transmitted by solid shaft, power transmitted by solid, power transmitted by solid shaft, by solid shaft, by solid shaft. Okay. So this ratio, that is means it is TH divided by TS divided by TS divided by TS. Okay. TS. So is equal to, this ratio is equal to, so TH it is how much? TH it is 2.670 into 10 raised to the power 6 into Fs divided by 1.570 1.5707 into 10 raised to the power 10 raised to the power 6 10 raised to the power 6 in terms of Fs. In terms of Fs, it will be get cancelled. Fs, it will be get cancelled. So this ratio it will becomes now, and 10 raised to 6 it will be get also cancelled. 10 raised to 6, this 10 raised to 6 it will be get cancelled. So 2.607 divided by 1.570. It will be 1.7. The ratio it is, our ratio it is 1.7. Okay. So power transmitted by hollow shaft by power transmitted by solid shaft, it is 1.7. Okay. So second question, now we'll solve the second question. Angle of twist, the ratio of angle of twist. Second question, the ratio of angle of twist. The second question, ratio of angle of twist, ratio of angle of twist, angle of twist means theta. Okay. So we know that equation, C into theta, C into theta, C into theta, C into theta, C theta divided by L, C theta divided by L is equal to Fs by R, is equal to Fs by R, is equal to Fs by R, Fs divided by R, C theta. Okay. So now, first of all, for solid, so we need to theta 1 is equal to here, theta 1 is equal to Fs into L, shear stress Fs into L, divided by C into R, means R into C. So R for solid it is, radius of solid it is Fs into L, radius for solid it is how much? So total diameter it is 200 mm. So radius it is 100 into C. 100 into C. So now for hollow, same here, theta 2 is equal to Fs divided by Fs into L, So radius for halo it is 250 by 2. External diameter is 250 by 2. So 250 by 2 it will be 125. 125 into C. Okay. 125 into C. Okay. So now theta 2 by theta 1. Ratio it is theta 2 by theta 1. Ratio it is theta 2 by theta 1 means solid divided by halo divided by solid. Theta 2 divided by theta 1 is equal to, so theta 2 it is Fs into L, Fs into L divided by 125 into C, 125 into C divided by theta 1 it is Fs into L, Fs into L divided by 125 into C, 125. Sorry, for solid it is 100 into C, 100 into C. Okay. So material it is same, that's why C it will be get cancelled, Fs it will be get cancelled. So length it will be also same. The solid shaft has the same cross-sectional area, has the same material with inside diameter. Okay. So length it will be also same. So L it will get cancelled. So now it will be 100 divided by 250, 120. 100 divided by 120. 100 divided by 120. The angle of twist it will be ratio of what? It will be 100 divided by 125. It will be at 0.8. So angle of twist it will be ratio it is 0.8. This one it is your final answer. So first power transmitted by hollow shaft to solid shaft it is 1.7, and angle of twist in equal lengths. So length it is equal, that's why it will be 8 cancel. Angle of twist in equal length of this shaft when stressed to the same intensity. So model to this it will be shear stress and this it will be get cancelled. So 100 to 125 will be 0.25. Okay, this is your final answer.